Hi viewers, Assalamu alaikum, good morning. In my new video on Mr. Sir M. Visvesvaraya and his works, let us welcome this video with his caption for all of us for our life: work well, earn well, and live well. Mr. Visvesvaraya is an esteemed engineer. Everybody knows we celebrate Engineers Day on his date of birth, on his birth, and we look him as an engineering face of India. Let us now see how he reached to the level of Bharat Ratna with a civil engineering degree, and let us have insight into his works he has done for India and for Indian people all over, and also at international levels. Generally, everybody knows that we celebrate Engineers Day on 15th September, his date of birth, especially for countries like in India, Sri Lanka, and Tanzania. Coming to his personal life, his date of birth on 15th September 1861, and at age of 15 he lost his father. Coming to the education, he passed BA from Central College, Bangalore in 1881, and diploma in civil engineering from University of Mumbai, and LCE, yani equivalent to bachelor's of engineering from Science College of Pune in 1883. After his education, his first assignment was in Nasik. He joined a public works department as an assistant engineer in Nasik in 1885, and where his job was to visit irrigation channels in the neighborhoods and attending repairs in progress to small anicuts and distributaries. Uh, one of his life instance, once there was a siphon work where he has to travel and he has to cross the river, and during his travel, when he crossed the river and he went to the certain place where the works are being done, it was raining very heavily, and he has to, and he stay there in that same village for 3 days, and he used to, people used to help him, and he was very strict in offering his services, and very disciplined, in a very disciplined way. And in 1894, joined as an engineering officer uh, for waterworks of Sukkur village, where his job was to plan supplying water from river Sindhu to Sukkur town. And in the irrigation design, he planned water filtration system for supplying drinking water from river Sindhu to Sukkur town. You can see here, Sukkur, was now it's a part of Pakistan. Mm. Almost there were 5 rivers we have in this location, and what the design was here, to pump the water into a reservoir which is on a higher side, and it is as close to the river bank. If you can see that scheme, you can understand what Mr. Viswesvaraya had done. Yani, seeing his works, what I got an impression that Mr. Viswesvaraya is a very, you know, he was a genius, especially in the wells. He has done, yani, in the forthcoming slides also I will discuss, especially in construction of the wells. What he has done is here, you can see here one river is there, and we have one pumping well is here, and if we see that near to the river bed, collecting water uh, from the flowing river, collecting water by percolation. But when the sufficient water is not collecting in the river, what he has done is he has constructed a tunnel from the river to the well, so that uh, the water can be collected at a higher proportions into the level. Then this water will be pumped to the reservoir, and here you can see almost he has worked in water supply and drainage irrigation systems almost half of the Indian cities: Dhulia, Surat, Pune, Kirki, Nasik, all these. Indore was also there, Nagpur, Rajkot, Bhopal also there, Bangalore, Ahmednagar, Baroda, and especially for these are the images which have been used for Hyderabad drainage disposal machinery when he was invited for Hyderabad, which we will inshallah will come in the next slides. Now Mr. Visvesvaraya has invented a block system, especially for the irrigation, and at that time farmers used to have disproportionate amount of water. So what he has done is uniformly distributing to the areas by using this block system, by using a network of canals and dams to distribute water for agriculture. And in the meantime, he has invented floodgates also, especially for Khadakwasla reservoir near Pune in 1903, which are used to raise the water supply level without causing any damage to the dam, and then supplying to the selected areas. Especially in this, the same system has been installed in Tigra Dam in Gwalior and Krishna Raja Sagar Dam in Mysore, Karnataka. So this was the publication in 1903, which has been published in the code, which is the distribution of water evenly as per need to the farmers. Sir Visvesvaraya also was invited to join Irrigation Commission of India in 1904 to 1905. He represented the Bombay government on special duty. And in 1906 and 1907, British government sent him to Yemen for taking up a design of water supply systems. And Hyderabad floods 1908, almost 20 Shamshabad, now the present airport. Generally we Andhra people, Telangana people, we go to the Shamshabad airport. At that time there was almost 12 inches of water, 12 to 20 inches of water accumulated in 2 days almost. Almost Hyderabad came under the floods. And at that time, Nizam has requested Mr. Visvesvaraya to draft designs. Actually, he has worked on two things, especially. One is in controlling the floods, and another is to maintain, to dispose the sewage and to stop the sewage from flowing into the river and preventing the mosquitoes. And he built a sewage farm also to not built any, he has designed it. And the design which Mr. Visvesvaraya has done, MV sir has done, it took some time to bring it into the shape, but it helps enormously in the formation of the present Hyderabad city, which generally Andhra and Telangana people should be very much thankful to this genius for his contribution. Actually, when we come to this, his marvelous engineering techniques, people generally, we work for only salaries. We see, we change companies. Even myself, we change companies. We see what is the finance we get in each company. But whereas when we see Mr. Visvesvaraya's work, we found that he has worked for the people, for the betterment of the people, for the betterment of the nation. And here in Krishna, another in 1909, he was shifted to Mysore as chief engineer for KRS Dam on the request of the Mysore ruler, Mr. Krishna Raja. And he was the architect of Krishna Sagara Dam, almost 107 feet height, almost around 40 meters. You can take it a 12-story building height, which was constructed with across river Kaveri river. And here the speciality is the mortar which was used in KRS Dam is Surki. And at that time cement was not so cheap in India when its production was not on its peak. So Mr. Visvesvaraya's genius that he has used Surki in place of cement, because it was very readily available. It used to, I will in the next slide I will mention how this Surki was made. Especially for, it's a stone masonry structure with a 2.5 kilometer span, and it took 20 years for the construction of this dam with an amount of 2.53 crores by Mysore state. And here, when we come to Surki, we have hydraulic lime, natural hydraulic lime with burnt bricks and sand, uh, with the ratio of 1:4. And regarding this dam, it is a non-overflow gravity type dam. Returns expected 3%, but they jump to 15%. Yani, in terms of production from the agricultural fields, in terms of electricity, in terms of so many things. So it gives almost 15% yearly. This is returns for the yearly. And regarding the Surki mortar, the speciality of it is it will not let the temperature rise when it sets, unlike cement. It is resistance to the its resistance to the temperature is very high. And also here you can avoid these construction joints, because generally when we design these industrial buildings, especially structural engineers, as structural engineers we face so much problems in CMU walls, where we give for every 5 meters this joint, any bond columns. And even in concrete structures, for generally for 50 meters we give expansion joints. So here, without any construction joints, this rubble and stones, as rubble and stones set in mortar randomly before they hardened. This is the KRS dam map. When we see this Kaveri river, and almost you can see here 2.5 kilometers dam, you can see it in the plan. And the excavation was done up to 48 miles, and this is the this at that time this dam created the biggest reservoir in Asia. KRS dam images, where you can see here this uh, block masonry work. And these are the techniques which Mr. Vishwesvaraya has used. When you can see in this image that we have one upstream side and downstream side with well. Here, the same well which we are talking here is a specialist of wells, Mr. Sir Vishwesvaraya. You can see here this dam was spread over 150 acres, irrigation around and 1.2 lakhs acres of land. See, this is the scope of a civil engineer. Mm. We always think that software engineers, mechanical engineers, everybody, electronical engineers are superior. But here, see, nobody is superior, in my view. And especially for civil, we have any largest scope here. You can affect thousands and lakhs of people. Seeing this, you can understand that how Mr. Visvesvaraya has affected the lives of the people. He uplifted the lives of the people around him, especially people of India. We should be very thankful for such an engineer. So we will discuss this how the water management system in the dams by using this well in the coming slides. See, this is the float system chain pulley mechanism. By using this float and chain pulley mechanism, this the by using this chain pulley, these chain pulley mechanism is connected with the gates. So once this float is due to the motion of this float, the closing and opening of the gates is related. You can see in the coming slides. This is another view of this wells and chain pulley system. At that time, this was an greatest invention by our engineer, Mr. MV sir. And here you can see this another image. These are the automatic gate, almost each weighing 10 tons. You can see here, this was erected in 1901 and sets 2 to 11 in 1903 and 4. Almost 10 tons each gate weight 10 tons each. Total there were 48 gates, this type of gates. This is the automatic door mechanism. You can see here the water level is it's not up to the mark. So such a generally, as in dry seasons, we don't have water, so at that time doors will be closed. And when your water level increases, this water pass through some siphon and it will go into the well. This water was injected into the well. This will increase this float level. By with this the level of the float, when it goes to the top of the well, by this chain pulley mechanism, this doors will be opened, and automatically water will you can see here 3D image of the sluice gates, and these doors will be opened when your water reaches up to a certain level in the upstream. So almost this canal irrigates 1.25 lakh acres of land. You can imagine the strength of a civil engineer, how we can affect, we can bring the revolution in the society, creating jobs, creating sustenance to the people. It's this canal irrigates 1.25 lakhs acres of land. You can see here some images where your water comes from the dam, and how the energy, can feel the energy with which this water comes. And really, when I remember in 2000 or 2001, when we went to this Nagarjuna Sagar dam, really I feel uh, the greatness of a civil engineer, what he can do. Really, these structures will give you energy, this inspiration, energy, because in this life can do as what we can do as an engineer. And these gates in the same year they were copied in the Panama Canal also. Yani the same gates which Mr. MB sir has proposed, and these are the patent of the sluice gate for Kadakwasla Reservoir on the name of our great engineer Visvesvaraya. And also in Vizag, there was a Vizag erosion problem was there, where Mr. Visvesvaraya has suggested sinking two ships to act as breakwaters to arrest the drift problem to the inner harbor. Yani, seeing all these techniques, you understand that whatever he has read, he has applied in his giving solutions to the problems. Generally, the problems solved faced by the engineering society. So in today's world also, all these metros, infrastructures, dams, and industrial growth, so these are all the problems, right, facing by the people. So we are giving solutions, we are giving the solutions. So there you have to one is the safety, and another is economy, and another aspect is environment. There are so many things to consider in giving solutions to the problems facing by the society. Mr. Viswesvaraya, especially in KRS Dam, yani, first of all, he requested, in his book, he has written the memoirs of my working life, that he has requested the king of Mysore to allow him to make some, advancements, and he believed him, and he succeeded. Bhadravati plant also similarly, in 1923 to 29 he has turned around the future fortunes of that iron works. And in the next slide we will see how how that plant was, how that plant faced problems, and how Mr. Visvesvaraya has uplifted it. And Mysore wood distillation and iron works in 1921 he installed. And generally this Bhadravati plant, wood was obtained from the forest that was converted into a charcoal through process of distillation. And yeah, this destructive distillation of wood was developed at ISC Bangalore at that time. And this charcoal was used to provide to produce the pig iron. This pig iron used to India used to export to the other countries like England, and also the charcoal blast furnace was the first established in Bhadravati in 1921. And after due to some mismanagement or some other factors, uh, there was huge losses for the plant. And again, MB sir has joined it as an engineer, as a chairman, and worked from 23 to 27, 1923 to 1927, and put whole things in proper condition, and again returned it back to the government. Mm. And in 1916 he started first Indian university, it is called University of Mysore. And then Kannada Literary Academy, and Sandalwood Oil Factory in Mysore. And this is memoirs of my working life, his autobiography. We should read it, how he carried his works, how he uplifted the lives of the people by using his engineering and his personal life. He is a very disciplined man. He used to have, very disciplined. And as as a corruption which is eating our countries, we should see his life. How he used to he used not to use his pen given by the office for his personal works. He used to use his lamp and pen also for his personal work. So such a level of such a level of purity, and such a level of what you can say faith he used to have. We should all live from his life, learn from his life. And in 1917, he helped in the formation of Government Engineering College of Bangalore. Later, it became Visvesvaraya Engineering College. And he also wrote two books on Indian economy: Planned Economy for India, Nation Building. We should read it. How he wants us to bring our life, to uplift our life in his books. And also, he worked in Ganga Bridge in Bihar. During his tenure as a Diwan, the following industries he opened: like soap factory, central sandal oil factory, metals factory, chrome tanning factory, Bhadravati iron and steel works. And in 1955, India awarded him with Bharat Ratna. Really, his hard work pays, and his sincerity got paid. He got Companion of the Order of the Indian Empire in 1911 by King Edward VII, and Knight Command of the Order of Indian Empire in 1915 by King Edward VII. And that's why, and he's called the father of modern Mysore state. These are the awards he received. So the feathers from Mr. MV Sir's life, some I selected. One is, if you buy what you do not need, you will need what you cannot buy. One day it will come where, if you buy what you do not need, then the time will come where you will need what you cannot buy. So you have to restrain yourself. And this is, remember, your work may be only to sweep a railway crossing, but it is your duty to keep it so clean that no other crossing in the world is as clean as yours. And another is, it is better to work out than rust out. Work hard. Hard work does not kill. It is worry that kills. And another is, work is worship, and service to the nation is the goal and purpose of all education and knowledge. Thank you, my friends. Please subscribe to my channel. And I think we all learn from his life, and we change our life's motto, that we should be any, rather, okay, our goal is to be earning, but at the same time we should do service to our fellow brothers, for our nation, for the whole world. As an engineer, we should we should give something to the society before we depart from this world. Thank you for watching my video.